Assalamu alaikum everyone. Good evening. Welcome to the webinar on nanoscale phase change memory devices. My name is Dr. Nafisa Noor. I'm an assistant professor at the Department of Electrical and Computer Engineering of North University, Dhaka. In today's talk, I'm going to present a general overview on the phase change memory nano devices. This presentation has been divided into 4 separate modules. After each module, I'll pause and take the questions from the audience. In the first module, we will introduce the semiconductor memory concepts. In the second one, we will compare between several existing and emerging memory technologies. In this module, we will also discuss about the importance of the new memory technologies like phase change memory or PCM. On the third module, we will introduce the concepts or fundamentals of phase change memory or PCM devices. On the fourth module, we will discuss about several reliability factors of the PCM nano devices. Welcome to the first module of today's presentation. In this module, we're going to introduce the concepts of the semiconductor memories. I'd like to start with some very general pictures of the global digital lives. Digital devices nowadays are becoming ubiquitous in our everyday life. Recent statistics of January 2020 shows that about 67% of the world's total population use mobile phones and 59% of the world's population use internets. From another recent statistics, we see that more than half of the global internet users use mobile phones, whereas the rest use mostly laptops and desktop computers. Besides these mentioned percentages of the world population, there are also people who use the laptops and desktop computers offline. Hence, the computers and other smart electronic devices have become an inherent part of human civilization. Now, whenever we go to buy any electronic device, we carefully check the specifications. The most important two hardware components that we check are the processor and the memory specifications. Here is an example of a good laptop computer. The memory specification of this laptop is highlighted in the yellow color as 12 GB RAM, where RAM stands for Random Access Memory. In addition to this, there is also 1 terabyte hard drive storage facility. However, if you look into the specifications of the high-end and newer laptops, you may notice that the hard disk drive is partially or completely replaced by the new forms of storage devices such as the SSD and Optane. These specifications clearly indicate that the memory and storage technologies are progressing rapidly, and people's demand are also changing accordingly over time. In general, people want to afford faster and smaller devices with low cost, high capacity, and low power consumption. In order to fulfill this growing consumer demand, semiconductor industry has been improving the memory device technologies for many decades. Starting from the 1940s, various random access memory and read-only memory devices were discovered for different purposes. In order to understand their roles in a typical computer, let's take a look at the memory hierarchy of a computer device. We can organize the memories used in a computer in a few different levels based on the speed of the memories, their cost, and the capacity that we can use. So on the first level of this memory hierarchy of a computer, we have the CPU register. These registers are extremely fast and they are used only of a smaller quantity because of the extreme high cost. These memory units are within the processor. They process the data and the instructions. The values are stored temporarily here. In the next level, we have the cache memory. The cache memory consists of the static random access memory or SRAM devices. The SRAM devices are also as fast, almost as fast as the CPU registers, and they are also used of a small quantity but slightly larger capacity than the CPU registers. And their cost is also slightly less than the CPU registers. Now here we temporarily store the data that are most frequently used by the processor. In the next level, we have the main memory, which is comprised of the dynamic random access memory or DRAM devices. These devices are slightly slower than the other two levels, and they can also be used with larger quantity as compared to the cache memory. And here the price is also slightly less as compared to the SRAM devices. Now, in the main memory, we store the data that the processor is currently working on. So these top three levels of the computer memory stores the data temporarily. And in terms of the cost, all of them are pretty high. And in terms of the speed as well, their speeds are quite similar. In the order of nanosecond, we have their write latency. So all these memory types are considered as very fast memory, and also at the same time we can call that they are very costly memories. Now, on the other side of the computer memory hierarchy, we have the permanent storage area. This is also called as the secondary memory or the mass storage area. So this type of memory is significantly low in cost and their speed is tremendously low. So here you can compare the speed of the other memories that are in the nanosecond range, whereas in this case, the traditional hard disk drive has only 10 millisecond for the write latency, which is 6 orders of magnitude larger than the DRAM write latency. So because of the very low cost, we can also use this hard disk drive of very large quantity. But the very strong problem here is that these are tremendously slow as compared to the main memory, and there lies a speed gap between the temporary memories and the permanent storage facilities. Now, in the traditional computer, where the hard disk drive is used as the only storage facility, there will be almost 6 orders of magnitude difference between the writing latency between the memories and the storage facility. So, the memories have to wait very long to receive the information from the storage devices. So, this large gap can be bridged with the solid state drive, which is composed of the NAND flash technology. But here you may notice that the write latency is not super high for this NAND flash technology or these SSD devices as well. So we can only go up to maximum 2 orders of magnitude higher in the write latency, but there would still be a large gap between the storage and the memory devices, and the problem is not still solved. Hence, nowadays, many emerging technologies are evolving, including the phase change memory that have the properties in the middle of the memory and storage devices. So the features that we have for PCM or its other counterparts, these features are in the middle of the memory technologies and the storage technologies. And that is why they can smoothly bridge the gap between the memory and the storage technologies. Besides the speed, PCM and its counterpart technologies combine several advantages of these existing memory devices and several advantages of the existing storage devices. For example, if we look at the volatility nature of these memory and storage devices, we see that the memories such as SRAM and DRAM are volatile, which means that when the power is turned off, the information stored in these memories will be erased. On the other sides, we see that these storage devices are non-volatile, such as the SSD and the hard disk drive are non-volatile, and that is why they ensure the permanent storage even when the power is turned off. So PCM and its other counterpart technologies combine the good side, which is the non-volatile nature. Also, there is another important memory feature which is called the endurance. The endurance number indicates the number of cycles we can cycle a memory without deteriorating of its features. So by maintaining two states, we can cycle the SRAM and DRAM up to 10 to the power 16 times, which is a very large number. But on the other side, you can see that the SSD, the NAND flash technology, has a very low number for the endurance, which is only 10 to the power 5. So PCM and its counterparts have the endurance numbers that are in the middle of the memory and the storage technologies. So combining the good sides from the memory and the storage technologies, this PCM and other counterparts of it are bridging the speed gap, and also they are basically working as a storage class memory, which is just in the middle of the memory and the storage facilities. So in our next module, we are going to discuss more about these comparative analysis between different kinds of memory technologies. Thank you for your attention on this module.